today's lecture. Today I'm going to talk about data visualization. Before we start today's topic, I'd like to introduce myself first. My name is Jie Qin. You can call me Dr. Qin or Jie. And this is my email address. If you have any questions, you can just feel free to email me. And I'm now the professor of communications at SCAD Hong Kong. The full name of SCAD is Savannah College Art Design. It's an American university, art university, which is very different from research universities. But regarding data visualization, I learned a lot from my colleagues, the artists and designers. And SCAD Hong Kong is the Hong Kong campus of SCAD. SCAD has 4 campuses all over the world, 2 in Georgia, the state of Georgia in the United States, and 1 in France, and the new one, the latest one, based in Hong Kong. And the SCAD is the first American institution which opens the Hong Kong branch. Guess which university is the second one? Sorry? No. American university. NYU? No, NYU opens is a branch in Shanghai, in Hong Kong. The answer is Chicago University. Chicago, University of Chicago, Booth Business School, the second one. So this is the trend. More and more American universities are opening Hong Kong branches, right? It's also a good news for the job hunters, for the fresh graduates, right? Okay, let's get back to the topics today. And today we'll cover 3 topics. The first thing is data visualization. What is it and why it is important? The second part, choose the best visualization that fits your data. How to choose the best visualization, how to choose the best graphs, tables, or other visualization formats for your data. And the last topic, data visualization in R. But I have to say that, I have to admit that R programming is not the best language for data visualization. If you really want to explore this field, if you really want to go deeper regarding data visualization, I highly recommend JavaScript or PHP, not R. But to keep the workshop consistent, so today we'll practice data visualization in R. Learn some basic plots techniques, basic plot skills, and also, if we have time, I'll talk about how to visualize maps, how to visualize social networks, how to prepare your visualization as HTML file and upload the HTML file to your website, because it's very important, right, nowadays to share your visualization works with people from all over the world. So far, any question? No? Any question about the topic? Or anything you know or you don't know? No? So if you have any question, just feel free to raise your hand, ask me.
Sorry, could you repeat the other 2 programs for visualization that are better than R?
PHP and JavaScript. Any other questions? No? Okay, let's continue. So the first part, data visualization, what is it and why it is important? In comparison with data collection, data analysis, I think this part, it's easier and harder. Easier because you just, right, draw something. Everyone can draw something, right? Everyone can draw the pie chart, bar charts, column charts, visualize the ideas in your mind, right? It sounds easier. Harder because it's a brand new system in comparison with the previous topics we covered yesterday and this morning. So I know it's afternoon, and today is a Saturday. But I really hope that you can pay attention to the lecture today and grab as many as things you can grasp today, okay? So I understand in the 3 hours, it's impossible to master all the skills of data visualization. So in my lecture, I'll try my best to offer as many resources for you. So after the lecture, I hope that you can read the readings I recommend, watch the videos I recommend, explore the code, the programs I recommend today, learn by yourself. And feel free to ask me any questions in the lecture and after the lecture. Okay, so what is data visualization and why it's important? Since you're not going to ask me questions, and it's my turn to ask you questions. So regarding the 2 pie charts, which one's better? Left one, right one? If you think the left one is better, raise a hand. Okay, the right one is better, raise your hand. Danny, just one hand. Okay, so the right side wins. Anyone? Tell me the reason. Why you think the left one is better? Any idea? Any idea? Why you think the left one is better?
Read from left side to right side.
Read from left side to right side. Any different idea?
Can it be both wrong? Can it be both bad or evenly good?
No.
No.
There's the answer. Why do you think the right one is better? Clockwise. Why clockwise is better?
Follow our natural sense of reading things and their operations.
Yes. The answer is the right one is better. Why? It's related with the reading habits, right? It's related with the human behavior. Because most of people read clockwise, right? From this part to that part. Right? So this is a very simple example of the principles of data visualization. Follow common sense.
But I have a question. If your focus is to show the minority, then the left one is better. If your purpose is to show who is the majority, the right one is better.
I agree that, but I have a better idea. If you want to highlight the minority, right? Maybe you can use colors.
But sometimes you cannot use colors.
You cannot use colors. I agree that.
Sometimes it's like black and white.
Right, but there's the better way to highlight the parts, right? But the common sense is that if you want to just report the results, right? It's better to follow, to put it clockwise, right? Put the larger part on the right, from right to the left. Any other idea? Different opinion. Of course, this is the example I got from the book. Actually, you can have different ideas, different answers. As you mentioned, what's your name, please? Pauline. Yes, Pauline just mentioned that if I want to highlight minorities, if I want to highlight the small parts, maybe it's better to put the small parts on the right and then the largest part, right? What if I want to just report the percentages, just the general percentages of my findings? Maybe it's better to put the largest part on the right side, right? Any question? Any idea? Okay, so the common practice is that put the larger part on the right and then the small parts on the left. Follow the reading behavior, put the parts that you're familiar with pie charts, right? But have you noticed the small things? So today I'll give you some tips, right? These small tips on data visualization. How to present your data better. Okay, I got this example from a book, and I highly recommend the book and the author to you. The title of the book is The Wall Street Journal Guide to Information Graphics, and this is the author, Donna Wang. She was the editor, she was the director of the information graphic department at Wall Street Journal. And this is a very good reading. I highly recommend it. And this is the cover of the first edition. And now I think the second edition has been published recently. So I highly recommend the book. In the book, the author mentioned that we live in a data-driven world where the ability to create effective charts and graphs has become almost as dispensable as good writing. Right? So this is the quote I like from the book, and I highly recommend the book to you. If you have time, please borrow the book from the library or buy the book online. Of course, you can always find free PDF versions online, right? Okay, so let's move on. What is data visualization? So data visualization is an umbrella term, usually covering both information and scientific visualization. Scientific visualization, information visualization, infographics. So today, since we're going to use R, right? We all know that R is a good tool to do data analysis, especially to visualize the tables, findings of our research papers, right? So today we're going to focus on scientific visualization. And The Economist, there's the article in Economist, there's another definition of data visualization. It is that there are 4 essential parts in data visualization: computer science, statistics, storytelling, and artistic design. We all know that computer science, right? For example, the R programming we're going to use today. And statistics, yes, you need to understand your data. Storytelling, narratives, how to tell the story in your data. What's the most important findings, stories you want to present to audience, to readers? The ability to tell the story. And the last part, artistic design. How shall I present the data? Which color, shape, right? Format I'm going to choose. It's related with artistic design. When we talk about data visualization, this example is must-know example in data visualization in the field. Anyone know this example? Anyone has heard about this example? Anscombe's quartet. Anyone? What is it? Okay, let's search this example, Anscombe's quartet, online, and try to figure it out. What is it? Why, when we talk about data visualization, we must know this example. Why this example is an excellent evidence to show the importance of data visualization. Please search the name of this example, Anscombe's quartet. What is it? What is it? You can download the PowerPoint slides from our Facebook group. Have you been added into the Facebook group? Yes? And also please log into the Facebook group. Later we're going to use the Facebook group to do in-class exercise. Anyone? Right? Do you find that? Do you find an example, right? Why we have to know this example when we talk about data visualization? This example is very classic and few, right? It shows that four data sets contain exactly the same statistical properties. For example, four data sets. When you calculate the means, the median, the mods, right? The statistical properties. The four data sets contain exactly the same properties. So you cannot tell the difference from the four data sets based on the statistics, right? But by visualization, we can see the difference, right? This is the classic example of data visualization. So in the future, when you introduce data visualization to your audience, to your readers, you will want to mention this in your lecture. Okay, so let's move on. Next, let's move on to the brief history of data visualization. So here is a very good paper. The title is A Brief History of Data Visualization. You can just search the title of the paper and find the PDF version of the paper online. And in the paper, there is the figure. The figure illustrates the important phases of data visualization, the development of the field. And nowadays, we're at this stage, right? We're at this stage. If you want to know more about the history of the development of the field, you can look at this paper, read all the physics and examples mentioned in the paper. So this is just a bird view of the field. So you may also want to include this part in your own lecture to introduce data visualization to your audience. And here, I like to mention how to evaluate visualization works. You can find many evaluation criteria online. For example, this one, accent principles for effective graphical display. In the principles, there are 6 criteria. First, apprehending, clarity, consistency, efficiency, necessity, and trustfulness. Right? You can develop different criteria to evaluate the quality of the visualization work. For example, apprehension. Does the graph maximize apprehension of the relationships among variables? Clarity. Are the most important elements of relations visually most prominent? Consistency, efficiency, necessity, and trustfulness. So the point I want to make here is that data visualization is all about effective communication. Right? You have to know your data. You have to know how to express the idea, express the understanding. You understand of your data to the audience. And you have to understand, you have to know all the visualization options, all the visualization devices you can use, and try to find the best visualization device for your data, right? So next, we're going to move on to the second part. Choose the best visualization that fits your data. So how to do that? For example, I prepare some bad examples, right? To show how bad a data visualization can be, right? For example, CNN news report, Hong Kong, right? This is a bad example of data visualization because it's totally wrong, right? And next one, Fox News. The title is the best pie chart ever. What's wrong with this visualization? What's wrong with the visualization? potion, right? The potion. And this one, right? This one. So what's wrong with this one? 3D pie charts. Cool, right? But this visualization is not functional, right? You cannot tell the information from this visualization. As I mentioned, the chart making process, first, you need to find out, you need to figure out what's the story you want to tell. You have to understand your data set. What are the most important, what are the most interesting findings in your paper, your data set? What's the story, right? So if you're not sure about that, go back to the introduction part of your research paper, or go back, reread the conclusion part of the paper, and try to figure out what are the most interesting findings of my research paper. Understand the data sets, understand the most important findings in your paper, and then rearrange the data. So this morning, Ginger mentioned a lot of things, how to clean the mess data set, right? And how to rearrange the data sets. And the last step, format the chart. In my PowerPoint slide, on page 20, I listed 6 common reasons why we need to use the chart. For example, when we compare two things, we usually use bar charts, column charts, scatter plot, pie charts, line charts, and table. Right? Have you noticed that? This one and that one, they're different. This is called bar chart, and this is called column chart. Right? So when we compare things, we usually use this chart to tell the difference of the two things. Right? For example, if we want to compare the percentage of female students and male students in the workshop, you may want to choose from this visualization options. The second one, to show the distribution. To show the distribution, we can use column chart, scatter plot, line chart, and boxes. When we need to show the distribution, an idea. For example, you usually see this box charts on the stock market, right? The trend of the stock market, the distribution of the currencies, right? And let's move on. The third reason why we often use, when we need to make a chart, to explain parts of the whole. So at this time, we usually use bar charts, column charts, pie charts, and table to explain parts of the whole. The fourth one, to tell the trend over time. We usually use column charts, line charts, and table. Here's the question. To tell the trend, as I mentioned, bar charts and column charts are different, right? So at this moment, why we choose column charts instead of bar charts? Any idea? Right. So regarding big data study, Professor Zhu mentioned that one characteristic of big data, of the online data set, is that timestamps, right? You can always see many trends, many timelines, right? When you want to visualize the timelines, the trend of the data set, you may want to use these charts, column charts, line charts, and table to visualize the data. And this time, never use bar charts. When visualize the timeline, always put the time, the dates on the x-axis. Never put the time, the dates, the year, the months on the y-axis. It's a common practice of data visualization. For example, if you want to talk about the 5,000 years history of China, right? Visualize the history of China year by year. 5,000 years. So you will have a very long axis, right? So this is an important tip I hope that you can keep in mind when you visualize the trend, the time series. And the fifth one, to find out deviations. To find out deviations, you may want to use this column charts, bar charts, line charts, and table to visualize the deviations. And the last one, to understand the relationship. Right? It's very common in our research paper. You may want to use this scatter plot, line charts, and table to understand, to visualize the relationship, right? So, any question about that? Can you memorize that? No? No. Please do not memorize that. Please try to understand. Try to understand. The point I want to make here is that you need to understand your data set. You need to understand the story of your data set, right? The story of the research paper. I want to do comparison. I want to show the relationship between the two variables. I want to find the outliers, the deviations, the distribution of the data set. Or I want to explore the time series, the trend of the data set. You have to understand your data. You have to understand the story you want to tell. That's the point I want to make here. It's really hard to memorize all these visualization options, all these visualization devices, right? And here I'd like to recommend 2 tools to help you choose the best visualization devices for your data set. So you can just Google chart chooser. Please Google chart chooser and you can find a website. On this website, you can choose the purpose of the visualization of your research project. For example, I want to do comparison. I want to show distribution. I want to show composition, trend, relationship, or table. This tool, this online tool, will give you recommendation on the possible visualization devices. So you can choose, you can combine different devices, right, to visualize your data set. And this is a very good resource. And next one, periodical table of visualization methods. What is it? What is it? Let's take a look at that. This is the periodical table of visualization methods. You can just Google the name of this website or copy and paste the URL I put in the PowerPoint slides. And you can see why I put the mouse here, right? So in this, and this website is also a good visualization of all the possible visualization devices, right? For example, there are 6 types of visualization mentioned in this web page: data visualization, information visualization, concept visualization, strategy visualization, metaphor visualization, and compound visualization. For example, data visualization, we can use table, right? Pie chart, bar chart, histogram, scatter plot, area chart, line chart, devices to visualize the data set, to visualize our research project. So as a summary, this tool and this tool, please take some time to explore the two tools. The two tools are very helpful to help you figure out what's the best visualization device you can use for your data set. So any questions? Okay, let's move on. So I'm going to skip this part, rearrange the data set, because Jie Qin has talked a lot about how to clean it up, how to clean up the data set, how to rearrange the data set. Here is just a simple example of the arrangement of the data set. For example, from the website, when you draw this data from the website, from the New York Times, from the news website, or from blogs, you may get something like look at that, right? You need to spend some time to reformat, to rearrange the data set. For example, from the fat data set into the tall data set. So I'm going to skip this part and to move on to the third part, format the chart. Here I list some suggestions, I list some tips here. So the first one, no non-zero axis scale on bar charts. So when you visualize your data set, when you report your research findings, always include zero axis scale on bar charts. The second one, make subtle grid lines or remove them. The third one, add labels to important points. Please keep that in mind, add labels to important points to highlight the most important points, the most important findings in your data set. The fourth one, add descriptive bold title position axis and skew at right places, for example, as mentioned, y-axis to the right on the large time series chart. And the last one, use simple, easy colors. Use simple, easy colors, right? So now it's time to the first in-class exercise. Here, I propose two questions. Consider the following cases and think about what's the best visualization you can use to visualize your data. The first case is that you want to compare the total visitors of 10 competing websites for the month of May. The second case is that you want to plot the breakup of traffic sources to your website. There will be 4 categories: direct traffic, search engines, referral sites, and others. So think about the 2 cases and get a piece of paper, sketch your ideas, and take a picture of your sketch and post the picture in our Facebook group. Now you have 5 minutes. Okay, thank you. I got 3 submissions already. So let's take a look at the submissions. First one, Jie Qin. Right, so you choose column chart and pie chart. Can you tell me one? For example, regarding first case, compare the visitors of 10 competing websites, right? Why do you think, for example, why do you think column chart is better than bar chart?
It's more easy to see the difference between
Why not pie chart?
because there are like 10 websites. You want to divide it up. I try. So then
Right, you're right.
it's very good.
This is a good point. Yeah, this is a good point. So the point I want to make here is that when you visualize the data set, always ask yourself, is there a better way to visualize that? Why do I choose this way, not that way? For example, the first one, I asked Jin Yuan, why do you think the column charts is better than bar chart? Actually, I do not have answer to the question. I don't know, right? So, but we can try. We can try different visualization device until we find the best visualization that fits our data set. And the second one, yeah, bar chart, pie chart, right? It's very intuitive, natural choice, right? Because you have to visualize the four traffic sources for your data set, just the 4, not 10, right? But in the first case, you have to compare the visitors of 10 competing websites. It's not a good idea to choose pie chart to compare 10 websites, but it's a good idea to visualize the second case using pie chart. Okay, let's move on to Kevin. The same choice. Kevin, the same choice, right? Okay, thank you. And Sam,
Yes, the same choice, but
the same, right?
for the home chart, I arrange them according to their number.
Mm-hmm.
And you can tell two things. You can compare it. You can also rank them at the same time.
Right, you're right. And it's very good you add labels.
Oh yeah.
Yes, include labels in your visualization. And this is very important. Okay, thank you. Danny,
Yep.
about the second case, which visualization device do you choose?
I don't know what it's called. It's like this one bar and then you divide it by, or I don't know what it's called.
Mm-hmm. Why do you think it's better than pie chart?
I dislike pie charts very much.
Yes, yes, I
strong,
agree.
I have a strong feeling against them, so I tend not to use them ever.
Mm-hmm.
That's why I chose this one.
Do you know what's the name of this visualization device?
No, I don't know what the name is.
You just invented it?
No, but it's
Yes,
even
I-
in Microsoft Word.
Direct traffic.
So it shows like the total amount. It's like a pie chart, but instead of saying pie chart, it's in a long form, and you divide it according to percentages as well.
Mm-hmm.
Maybe pie chart is better. I don't like it.
I agree, yeah. So the fun part of data visualization is that you can always try different visualization devices until you find the best one, right? And Cynthia? Yes, also the same choice, right? Column chart and pie chart. Okay, thank you. Amanda?
Also the
Pie chart, yeah. It's very good. It includes titles and also labels in your visualization. This is very important. Central Park. Okay, it's interesting, right? It's interesting. Line chart. Why do you choose this line chart to visualize? Okay, so for example, the 4 sources, right? Direct traffic, search engines, referral sites, and others. We call this as categorical. Right? So when we have this categorical skills, it's not a good idea to choose line chart. It's always better, right? For example, we want to tell that want to compare the four different sources. For example, we want to compare different religions. We want to compare different genders. This categorical variables. When we deal with the categorical variables, line chart is not a good idea, right? Because, for example, the line chart, how to interpret this part? What's the connection between direct traffic and search engine? No connection, right? There's no connection between two categorical variables, right? And this is, thank you very much. This is the case I'm going to talk about later. Yeah, this is the common mistake I always see in data visualization. When we deal with categorical variables, for example, the four types of visitor sources, right? Different religions of the world, genders, right? When we deal with the categorical variables, please do not use line chart because it's impossible. The connection between different variables do not make sense, right? So this time it's better to use column charts, right? Because there is no connection between the two variables. Okay, let's move on. Polling. For the second one, you choose pie chart, and for the first one, you choose bar chart. Why do you think bar chart is better than pie chart?
Because usually, as you mentioned, it's about the time, but this is the same month, it's all me. So I think there's no like time sequence. So I try to choose a chart that can from the most frequent visits to the least frequent visit and put it in order. I think it's easier to understand.
And you use different colors, right? Different colors to highlight different websites, right? This is very good. I like your point because it's not relative. It's not relative with time, right? You just want to report the visitors in 1 month, right? Okay, thank you. Mickey Wong.
Michael, actually, I want to use one pie chart, but it has two different parts. The inner pie chart have 10 different websites, and each website will be highlighted by different colors, the four different colors to show the percentage of the different, such as the search engine and so on, like that.
Oh, you combine two cases together, right?
Yeah.
Okay, now I get the idea. Yeah, you combine two cases together. Okay, thank you. Very creative. You just invented a visualization by itself. Okay, that's all the submission I got so far. Due to the time limit, I cannot give you extra time to do this in-class exercise. The point I want to make here is that when you visualize the data site, always ask yourself, is it a better way to visualize it or not? Try different visualization devices until you find the best visualization that fits your data set, right? And pay attention to the details in the visualization, for example, titles, labels, colors, layout, position, placements of x-axis and y-axis, right? Pay attention to the details and also zero scheme. Zero, always include a zero in your visualization. Okay, this is the point I want to make here. And after the exercise, I like to discuss 3 cases. The first one, tables versus graphs. As I mentioned, we can find many visualization devices, right? For example, when we write our research paper, we can use tables, we can use graphs to visualize the data set, right? For example, I have a case here. Assume that we are human resource managers, and there are 3 candidates. We interviewed 3 candidates according to 6 areas of competence, experience, communication, etc. What's the best way to present the qualifications of potential hires? Right? For example, in the morning, you may get an email from your boss. Would you please help me visualize the data set to help you make the decision? Which candidate is the best candidate for the position? So this time, you will choose tables or graphs. Here, I list the 2 visualization devices here. Radar chart and tables. Which one is better? Radar chart is better? Do you think radar chart is better? Yes? Why?
It's easier to spot each.
What do you think is better than table?
But it's easy to spot. For example, for this position, I may pay more attention to education experience. To go for the one, for the excellent age and the records, and it's just more effective to spot.
If you think this is more effective, right?
Yeah.
So if you are the boss, which candidate will you choose based on this radar chart?
No, it depends on the position. What kind of exam? Which I don't know. Like you think communication. Oh, is it human resource manager? Is that a position or what? I don't know. Depends on the job position. Right?
I don't know. I don't know the details about the position.
Yeah. Maybe the blue one. It's a safe. It looks like this candidate is kind of an average in everything. Not specific aspect is too outstanding, but it's okay in all aspects. I think it still depends on the position.
Depends on the position.
Yeah, communication friendly for some position like the reception desk, where we want them to hospitality or hospitality and all these
Thank you. What's your name? Jeannie. Thank you. Jeannie. Jean. Thank you. Any different idea? Who think table is better? No one?
I prefer table, but I will highlight the best.
So based on the table, which one is the best
No,
candidate?
I mean, on the table, I will put some highlight, so it's easier to read. But now it's very difficult.
No, it's very different, right? Any idea? Any different idea? If you are the boss, which visualization will prefer? Radar chart? Table? No? Why? nominal skew, ordinal skew, please do not use line chart. Okay? For example, west, north, east, southwest. The connections between these variables do not make sense. So this time, please use bar charts or column charts instead. When you deal with interval skews, you can always use line charts because the connections between different points have meanings. Okay? This is a very important, and this is the common mistake I encounter all the time while I read papers. So please keep that in mind. The next case, where to display each variable. So if the graph displays a single categorical variable, it's very easy, just associate with one of the axes. So with line graphs, you may need to visualize two variables. So you should always position the categorical skews on the x-axis, horizontal, and quantitative skews on the y-axis. But as I mentioned, when you visualize time series data, when you visualize trend, put the time, the year, the months, the minutes, the time to the right. Get that? Please keep the tips in mind. Okay, next, we're going to write codes. Are ready? Okay, let's go to our Facebook group. Go to files, and you can download the zip file I uploaded yesterday. Did a visualization for uploads, and you can find all the codes we need today. And now please download the package and try to find a file titled database.r. Go to Facebook group, download the package, and try to locate a file titled database.r. Do you get that? Do you have R or R Studio on your computer? Okay, let's do it. In this package, you can find the proper slides of my presentation, and the file contains all the codes we're going to use today. And there is a file titled sample data. We're going to use the sample data for exercise today. The sample data, I collected the sample data from Weibo. So it's about the followers, number of followers, gender of this Weibo, and number of followees, some numbers about this. And the last file, Twitter activity users, right? Do you still remember the homework from Professor Jules, right? Did you do that? We're going to use the same data set, the Twitter data set, the Twitter activity users. The homework today, you're going to use any R packages to visualize the time series, to visualize the data set, and present the most interesting findings in your data set. Okay, so you can open the file titled database.r and find all the codes we're going to use today. Okay, open it. Do you see that? So in the codes, you can see that there are there are 7 parts. So first, I'm going to I'm going to take you review what you learned yesterday and the day before yesterday about R, how to set working dictionary and how to do simple calculations with R and how to import and export data sets into RStudio or R. And after that, I'm going to introduce some basic plots in R. For example, how to visualize the gender distribution in the data set, how to plot bar chart, pie chart, colors, and use colors, histograms, and dot chart to visualize the data set. And after that, I'm going to introduce two visualization packages. The first package is called Lattice, and the second package is called ggplot2. You can find all the information, all the topics we are going to cover in this PowerPoint slides. I've included all the tools, all the name of the packages in the PowerPoint slides. For example, ggplot2. This is the most famous R package for making beautiful graphs. And there's another package called ggbees. You can make interactive web-based graphs with the graphics. So do you understand what's the meaning of interactive visualization? What's the meaning of interactive visualization? Right. So for example, on the website of New York Times, you can find many interactive visualizations. For example, you can choose the year, right, to visualize the, for example, visualize the GDP of the country. You can see the map and click the country, and you can see this statistics of the country or the year, right? And this package is a very good package for interactive web-based graphic design, web-based visualization. And there are other packages like RGL, HTML widget, and Google Viz. Do you know Google Chart? Have you ever used that? I think Google Chart is also a very good tool for data visualization. As I mentioned, the Tech Talk. The Tech Talk I was supposed to show you today, but which I failed to do that due to the microphone issue. The Tech Talk, the speaker of the Tech Talk, Hans Rosling, he invented the tools called Gapminder. And Gapminder was purchased by Google Chart, was purchased by Google, and now it becomes Google Chart. Right? This is a very good tool. You can use these packages, the different packages, to do many things. And other resources I want to mention here is that if you want to learn more about R graphs or R visualizations, you can Google R graph gallery and find many examples online. What you can do, what visualization you can use, what tools, packages you can use for data visualization. And there's another website I want to highlight here is that there's a website called R4Cats. R4Cats is cute, right? R4Cats. You can Google the name R4Cats and find the website. It's very useful. You can always find many good tips, examples about the basic functions for R and visualization examples in R. R4Cats. So keep the two websites in mind, R Graph Gallery and R4Cats. Okay, so these are the resources I want to recommend today. And now let's do one thing. Search R for Beginners. This is a book. Search R for Beginners. We're going to read the graphical functions in R in this book. for beginners, and go to page 40. This is a very good guidebook for you to learn art. Chapter 4, graphics with art. It contains everything you need to know about how to use, how to visualize data by using art. And on page 40, graphic functions. So this is an overview of the high-level graphic functions are, for example, plot x, plot xy, sunflower plot, pie, bar, multiplot, coplot, matplot, dot chart. Let's spend some time to read this. I think it's an important part of learning process. When you learn data visualization by yourself, I highly recommend you start from this guidebook, Art for Beginners. Read chapter 4 and spend some time to read the graphic functions. So these graphic functions are like the functions you can use in Excel. For example, you want to do the calculation, you want to calculate the total amount of something, right? You may need to use the function sum. In R, when we want to draw something, the most frequently used function is plot x. Plot the values of x ordered on the x-axis, right? And if you want to plot the bivariate, if you want to plot two variables, you can use plot x, y. If you want to use pie chart, box plot, or matplot, what functions you can call in R programming. This is the very basic standpoint for you to learn data visualization. This is the graphic functions. And on page 43, section 4.4, graphical parameters. So when you visualize data set, you may want to change the color of the visualization, the line, the symbols in the visualization, right? So what functions, what elements you can change, and how to change the color, how to change the background color, and how to change the font size. So this is all the basic things you need to learn about data visualization in R. So if you have time, spend some time to read this chapter 4. Okay? And now let's go back to the codes and start writing it. Do some practice, do some exercise by using the data set, sample data I put into the package, okay? So try best to follow me. If you cannot follow me, you can just copy and paste the codes in R and practice by yourself. Okay, and now the first step is I just open the codes, right? And the first step is set the working dictionary because this is what I usually do when I use R because it's much easier to load data set. For example, the working dictionary is documents. So I always put the data sets or the R codes in this working dictionary. When I need the data sets, I just need to use this command load sample data.r data. I do not need to type the long name of the data set. That's the benefit you set in the working dictionary. Okay, as a warm-up, let's do some simple calculation. For example, A equal 77, A plus 88, right? It's a simple practice. And next, do you still remember the different vectors mentioned by Dr. Liang Hai? What's the meaning of vectors in R? Right? Different data formats, right? For example, this example, I want to know the length of this string vector. I just type, for example, this is the vector, this is string vector. I define the vector as apple, banana, kiwi. And I want to know the length of the string vector is 4, right? It means the vector contains 4 strings, 4 words, right? And next, let's draw a matrix. So this is my matrix. I just copy and paste my codes from this file to save time. So see, this is how to define a matrix. Do you still remember how to define matrix in R? Okay, this is the simple warm-up. And next, we're going to load the data set. As I mentioned, the working dictionary for me is documents. And I've already put the sample data, the data set into documents. So I just need to use the simple command line, load sample data. And this is how the data set looks like. Can you load the data set and open it? So the data set contains the following variables: user gender, the gender of Weibo users, and number of followers, number of friends, user status, and user favorites, user geolocations, and user created at what time, and who followed the user by follower count, verified or not, verified type and issue. Contain these variables, and they were not going to use all the variables. We are going to use, for example, user gender. So first, let's take a look at, let's visualize the gender distribution of the users. Okay, so when you load the data set, first of all, you fetch the variable. You use this command line to define a vector. Define a vector G using this command line. Read table, sample data. This is the title of the data set, right? You want to fetch user gender, this variable from the data set. So you type table, sample data, $, user gender. Use this command line to fetch this variable from the data set, right? And now I want to see how many females and how many males are included in the data set. I just type G. This is the result. So in a data set, there are 39 females and 213 males. Do you get the result? Yes? Okay, now let's visualize. Let's try different command to visualize the data set. So for me, if I do not know which visualization device is the best for my data set, I will just use plot G, this command. Let R to visualize the data set for me. Let's see what we get. This is what I get. Can you get that? Yes, right? And now let's try another visualization device. Let's try bar plot. Right? Do you get that? Bar plot. And next, I want to add title. See, this is the bar plot, right? 0, 50, 100, 150, and 200. And so far, I do not input the title into the visualization. So how to add title into this visualization? So this is the command line we're going to use. Bar plot G men equal gender distribution. Now the graph has the title. Can you follow me? Yes. If you cannot follow me, you can just copy and paste the codes from the file. Okay, so next we're going to add label. So how to do that? We're going to use y label equal number. Use this command to add label to y-axis. You can see now there's a label here, right? So let me repeat the whole process. First, I want to get this variable from the data set because the data set contains more than 10 variables, right? I want to get the variable gender from the data set. How to do that? So I use this command line, the title of the data set, $ user gender, and define this variable as a vector G. This is what I did. After that, I want to see the variable, the basic statistic of the variable. What's the gender distribution in the data set? So I type G and see the result. So in the data set, there are 39 females and 213 males. And now I'm going to visualize the data set, right? But now I'm not sure what's the best visualization device I can use to visualize the data set. So I just use plot G. So I leave the problem to R, to the software. Let the software decide which one is the best visualization device. But based on the results I get, this is not the best way to visualize the gender distribution, right? So now I want to try other visualization devices. For example, I want to try bar plot. So I type bar plot G. It's better, right? It's better than the automatic generated plot by the software. Can I try different? I want to add something new into the visualization. For example, I want to add the title. So far, there's any title in the visualization. How to do that? So I use this command line, bar plot G men equal gender distribution to define the title. Define the title of the visualization. See? This is how to define a title. And now I'm going to add label. As I mentioned, labels are very important in data visualization. How to add label? How to add labels? For example, I want to add label to y-axis. How to do that? I use this command line GYLab equal number to add label into the visualization. Right? So how to add title at the same time, add label? How to do that? I'm going to copy this command. This is the command we use to add title into the visualization, right? Men equal gender distribution, comma, and ylab equal number. This is the command line we use to add label into the visualization, right? So add title and label. Let's see what do we get. See? Now we got a bar chart, and the bar chart has a title and a label. So now the question is how to add label to x-axis. Yes, all right. Okay, so next let's try pie chart. If you want to use pie chart, I just type pie chart, G. Oh, it's wrong. Why is wrong? Arrow couldn't find function pie chart. What's wrong? Why? What's wrong? Yes, you're right. That's why we need to read the cookbook. We need to read the guidebook like for beginners. We need to figure out how did the function, is the function defined in our programming, in the software, right? So in R, we call the function. If you want to visualize, if you want to draw a pie chart, we use pie instead of pie chart. So now I'm going to type pie, G. This is what I get, right? Now the question is how to add title to the pie chart. Men equal, right? Men equal gender distribution. Let's try. Yes, you're right. Now the pie chart has the title. And how to add labels into the pie chart? Y-X equal, right? Y-lab equal, X-lab equal, right? Let's try. It works, but it's not the best way to do that, right? Because in a pie chart, there isn't y or x axis, right? So how to do that? So for example, now I only got M, right? F for females and M for males. How to add labels? For example, I want to add percentage to this pie chart. I want to add the full names, full labels, females instead of F, males instead of M to the pie chart. How to do that? How to do that? Okay, now it's time for break. I leave the question to you guys. I'm trying to figure out how to add labels to pie chart in R. Okay, now tea break. We'll resume the class at 3:45. We usually use in R, and how to load sample data we're going to use to visualize today. And we practice some basic plots like bar chart, pie the this is the pie chart we just made, right? And before the break, I give you a question: how to add labels to the pie chart? An idea?
You have labels there, labels there, and then you rename them.
Rename it.
I mean, what do you learn? You have M and L with.
I want to, for example, I want to add females instead of F.
So rename them.
Rename them, yes, how to rename them, and I also want to put percentage into the pie chart. For example, 90%, 80%. So how to do that?
I know what to change the name. And just use the name function.
Yes, use the name function. Yes, you can just change the name. Any idea how to, for example, add this annotated information? Add any information you want to add into the pie chart.
Labels equal names. But I didn't.
Yes, yes. You are on the right direction. Label equal name, right?
Names.
Names, yes. Very good. Labels equal names, right? And next, I'm going to tell you how to change colors. So this color, blue, white, is the default color. Now I want to change the color to, for example, black, right? So how to do that? There are the command lines we're going to use to change the colors. First of all, I'm going to define a vector colors. Color is equal to C. Define the plate as black gray. You need to define the vector first, and then use the vector to change the color. This is the logic to change the color in our visualization. Define a vector, just like define the plate, define the color plate. On the plate, you have black, you have blue, you have yellow, you have red, but you need to define the color plate first. After that, use the plate to change the color of the visualization. Okay, I'll do that. For example, I'm going to define the plate as black gray, and I'm going to change the color of the pie chart. So attention here, the default colors include white and blue, right? And now I'm going to change that into gray and black. What I did is that to define the color plate, black, gray, and use this function, COL equal colors, to fetch the predefined color plate. So that's the logic to change the color in our visualization. Do you get that? So let me repeat the whole process. What I did, define the color plate first. Colors equal C, black, gray. And then use the function pi g color COL equal colors. Use the color plate to change the color of the pie chart. Okay? So now I'm going to ask you, if I want to use yellow and red, if I want to change the color to yellow and red, how to do that?
So you either change the colors vector or you create a vector with different colors.
Yes, great. Now I'm going to define another color plate as colors 2. Here, I tap red, yellow, right? This is the color plate I defined, right? Red, yellow, and I'm now going to use the color plate to change the colors. I use the function col is equal to color2, the predefined vector, the predefined color plate to change the color of the graph. This is the new visualization I got. Can you follow me? Right? That's the logic. Define the color plate first, and then use the function col is equal to code the color plate, to use the color plate to change the color. And next, I'm going to show you how to visualize the data by using histogram and dot chart. And now we're going to use another variable in the data set. So previously we used the variable gender in the data set, right? And now we're going to use another variable, user followers count. The number of followers that a user has on Weibo. We're going to use this variable. So how to use the variable? This is the command line we're going to use. I define a new vector, use this function as numBreak to call to use this variable, fetch the variable from the data set. This is the command line. F as numBreak, sample data. This is the title of the sample data. This is the title of the data set. $, user followers count. This is the title of the variable. Can you follow me? If you cannot follow me, you try best to understand the logic of the command line. You can just copy and paste the command line in R, right? And I'm going to see, right? What do the numbers mean? Number of followers the users have on Weibo, right? And now I'm going to visualize this variable. But now I don't know what visualization device, what chart I'm going to use. What chart is the best visualization method to visualize the data? So what should I do? So I just use the function plot, right? Let the program, let the software decide which is the best visualization for my data set, right? Plot F. The program choose scatter plot, right? Is it good? I don't know, maybe not, right? So now let's try other visualization devices, for example, histogram. So what's in R programming, histogram is defined as the function haste followed by the vector. Haste F, enter. This is the distribution of number of followers. See that? It's better. Maybe it's better. So this is the automatic generated plot. And this is the histogram of the variable. Okay? So when you do data visualization in R, you can always use different visualization devices. Just use it and compare which one's better. For this histogram, and I'm going to define the base of the histogram. This is the command line I'm going to use. You can see that if I do not use the command line, the function breaks equal. This is the result I got. If I use the breaks equal the function to set bins, this is the result I got. We can use this function breaks equal to set bins for the histograms. And now I'm going to change colors. Change the colors, add some color, add some colors into the histogram. How to do that? Breaks equal 20, color equal light blue, border equal pinks. This is how I add colors into the histogram. And now I use light blue and pink to do that, right? I now want to change the color into, oh, sorry. I want to change the colors into, for example, black. And to change the color of the border into yellow. This is what I get. Can you follow me? Okay, this is how to change the color in a histogram. And now I want to add a title into the histogram. How to do that? What's the function we're going to use? Man. Yes, right? The function we're going to use is man equal followers distribution. See? Now the visualization has the title. And next, I'm going to label x and y axes. What's the functions I'm going to use? X lab is equal to number of followers and y lab equal to frequency, right? Now it looks better. Now the histogram has a title and has two labels. I also set themes of the histogram and add colors into the visualization. And next, let's try dot chart. If I want to use dot chart, I just type dot chart, and this is what I get, a dot chart of the distribution of followers in R. Similar to histogram, if I want to set range. Set range to 1 to 30,000. Set range. If I do not set a range, the default range is from 0 to 250,000, right? But you can see that we do not need that range, right? I want to change the range to 1 to 30,000. This is what I did. I use the function xlim, xlim. It means x limit. Set limit to x-axis. xlim is equal to range 1 to 30,000. And you can see the range now is changed to 30,000. Right? This is the these are the basic plots we can use in R. So if you have time, I highly recommend the book R for Beginners. Read chapter 4. Take a look at all the functions, all the visualization devices we can use to visualize the data set. For example, which is mentioned the pie charts, bar charts, bar plots, histogram, dot charts into this class. But there are more visualization devices you can use. Take some time to read the chapter 4 and figure out what visualization devices are available for you. Okay, so next I'm going to introduce two packages. Why I'm going to introduce the packages? Because, for example, to be honest, as I mentioned at the beginning of the class, I don't think R is the best visualization tools we can use, right? For example, this one. It's okay. It's okay, but it can be better, right? It can be better. Now, how to make it better? To make it better, we need to use some advanced packages. Packages made by designers, right? Not made by statisticians, right? And today I'm going to introduce two packages. The first package is called Lattice, and the second package is called ggplot2. ggplot2. And for this part, you do not need to do it by yourself. If you can follow me, yes, you're welcome to type the codes and see what you got. But for this part, I'll just show you, I'll just do some demonstration for you to show you what results you can get by using these packages. For example, I'm going to use I'm going to use a data set called diamonds attached into the data set, into the package. I'm going to install package lattice. And install the package ggplot2. And I'm going to use the data set titled diamonds. Data diamonds. Yes, it's ready. What is the diamonds data look like? If we want to know more about the data set, we can type question mark and the title of the data set, and we can get this website. So this data set contains prices of 50,000 round diamonds. All the information about diamonds, right? Description, usage, format, details. For example, this data set contains variables like price, carat, cut, quality of cut, color, right? Are you familiar with diamonds? Right? No? For the gentlemen, you will get familiar with diamonds someday. Right? Okay, price, carat, quantity of cut, color, right? These are the important parameters about diamonds, right? And now we're going to use, I will use this data set to demonstrate the two package. First of all, I'm going to draw something. XY plot. There is a function called XY plot. By seeing this, you can see this is a relationship between two variables in the data set, right? Carat and price. The happier the diamond, more expensive it is, right? It's common sense. And now I'm going to add a third variable into the plot. price carat by clarity. Right? So for diamonds, there are different levels of clarity. The clearer the diamond is, more expensive it is, right? And now I just add the third variable into the visualization. This is what I did. I'm going to repeat the process. First of all, I use this XY plot function to visualize the relationship between the two variables, price and carat. This is what I got, right? And I use another command line to add the third variable into the visualization. I want to see the relationship between price, carat, by clarity of the diamond. So this is what I did. And next, I'm going to show you how to draw bar chart by using the packages. Bar chart, table cut. It looks better, right? It looks better. I give the function bar chart, table cut to visualize. And now I want to change the position of the bar chart. As I mentioned, bar chart and column chart, they're different, right? This is what I did, bar chart. Right? And now I set the horizontal to false, set the parameter to false. This is what I got. See, this is, you can use the parameter to change the position. And next, I'm going to show you some functions of another package, ggplot2. For example, I'm going to use the Weibo data, which is the use for the basic plots demonstration. And now I'm going to use define a vector code f1 by using user follower count, the number of followers the Weibo user has. And I'm going to use qplot function in ggplot2. Set status being B1 default range, use B1 to adjust this. Okay. I'm going to this is what I get. And I'm now going to use the same data, the diamond data, to show you some functions of ggplot2. For example, I want to see the price distribution of the data set. This is what I got, ggplot2. There is a function similar to plot function in R. It's called qplot in ggplot. This is the distribution of the price of the diamonds in the data set. And now I'm going to show you how to draw a scatter plot by using the qplot function. Qplot current price data, similar to what we got from lattice, right? The relationship between carat and price looks better than the default R package, right? That's fine. That's fine. We need to use this advanced packages. And now I'm going to change the color. I think black is boring. I want to change the color of the dots. And I want to change the color of the dots by clarity. carat, price, data, diamonds, color, equal, clarity. Looks better, right? This is what I did. First of all, I use qplot function in ggplot2 to visualize the relation between two variables, carat and price. And now I want to, this is what I get. Step 1, right? Step 2, I want to change the colors of the dots. I want to change the colors of the dots by clarity. And I add something into the command line. Color equal, I use the function color. Color equal, this one. Color equal clarity, and press enter. You can see the relationship between carat and price. And all the dots are colored according to clarity of the diamonds. It's pretty, right? And now I'm going to do log transformation of the data set. Makes more sense, right? I just did the log transformation of the data. And in the file titled database.r, you can find the last part is called packages for interactive data visualization. Because today we do not have enough time, we are going to take a